Hi friends, welcome to the unit number 4 of AVM, and we are discussing correlation and regression topic. So first of all, in this chapter what are the topic which we have to discuss? First of all, we will see the objective. पहले हम लोग objective देखेंगे. Then after we will see the introduction part, right? We will see the introduction. Then after we will see the scatter diagram, right? We will look at the scatter diagram, how it works. Then we will look at the correlation, we will look at the regression, we will look at the standard error of the estimate. So these are the 5 topics which we have to go through in this particular chapter. So let's start with the first topic, that is introduction. Have you ever wondered if a good education really guarantees success in life? So have you ever wondered if good education really guarantees success in life? We always hear that studying more lead to higher income, but it is actually true? Let's break it down in simple terms. Imagine we take a sample of 50 individuals, right? So you can see here that we take a sample of how many individuals? 50 individuals. Okay, and we record two things. The first thing we record is the number of year of education. That means year of education is the first thing we record. And the second thing we record is the annual income. Means year of education means what? How long they have studied. How long they have studied, right? This is the first part. And second part is annual income, means what? That how much they earn. So these two things we have recorded for this 50 individual. Now what we are checking, we want to see if there is a correlation, meaning does more education means more money. So we want to check this thing. What we want to check? We want to simply check is more education, does it means that more money? We want to check this correlation, right? Okay, and if so, can we even predict someone income just by knowing how many years they studied? That is where regression come into picture. So correlation help us know that if more education is equal to more money, this we can predict using correlation, right? This we can check within correlation, and if it is so, then we can predict someone income just by knowing how many years they have studied. And for prediction, this regression comes into help. Okay, so this study focuses only on education and income, but in reality many other factors can affect success, like skill, experience, and even luck, right? This particular study focus only on education and income, but in reality what happens, there are many factors, right, which can affect a success. Like what are the factor? Like skill, experience, and even luck factor. So what do you think? Does education alone determine success? Drop your thought in the comment. Do you think that education alone determine the success? Now so I hope this is clear that correlation aims to determine if there is a correlation between education and income, and regression means we predict annual income based on the number of year of education. So that is what correlation and regression is all about, right? So that is our focus here. Now let's shift our focus to the next topic, that is a scatter diagram. So have you ever heard the phrase? Let me write down the phrase for you. So tell me, have you ever heard the phrase that number don't lie? I hope you must have heard this phrase that number don't lie, right? But what if we could see the number speak? That is exactly what a scatter diagram does, right? Through a scatter diagram we can see that number is speaking. It is super simple way to visually understand the relationship between two things. So suppose we have to understand the relationship between two variables, so we can easily do it using the scatter diagram. So that is the benefit of having the scatter diagram, right? So let us give a simple example to make you clear. Imagine a school principal wants to check if a student who score high in entrance exam also get final graduation GPA. So first of all, the one variable is entrance exam score, that this principal want to check if a student score high in entrance exam also get high final GPA, high final graduation GPA, right? So instead of just looking at a bunch of number, they plot data on a graph, right? So what they do, instead of just looking at a bunch of number, they plot data on a graph, right? So it helps us. So question is why graph? Obviously the pertinent question is what? The pertinent question is why graph, right? Why graph? So the reason why graph is needed, because it helps us see the pattern, right? Because this particular graph, it helps us see the pattern, right? That is why graph is needed. We can see the pattern which is here, and I can show you this particular figure. We can see this figure, right? So graph is needed because we can see the pattern. It shows, this graph shows whether two things are connected. So graph shows, first thing it shows is pattern, second thing it shows that whether two things are connected, that means correlated, and the third thing is, so it make decision making easier, right? We can easily make the decision. So what we learned from there, that is a scatter diagram are like X-ray vision. You can call it like X-ray vision. So they are like X-ray vision for number. They help us spot trend and make a smart prediction, right? So have you ever noticed a pattern in your studies or work? Let me know in the comment. Now let's talk about the methods which we use. So what are the methods which we use? So here we are talking about what are the methods which is used in a scatter diagram. Let's talk about the methods now. So imagine if we could predict the future just by looking at the past number. Sound cool, right? Well, that is exactly what a scatter diagram help us to do. They turn raw data into clear pattern, making it easy to see connection between two things. So in simple word, I can say that what they do, let me write it down. So what they do, they convert raw data into pattern. They convert raw data into pattern so that we can see the connection, right? So this scatter diagram help us predict for the future. So scatter diagram turn raw data into clear pattern, making it easy to see connection between two things. So since raw data has been converted to pattern, so we can easily see connection between two things, right? So this we can easily see connection between the two things. So let's break it down using an example. So do a student, let's take a college principal, let's look at what a college principal wants to know. Just now we have talked about in the previous case. Do a student who secure high in the entrance examination also get high final GPA? To find out, they collect random student data. So you can see in this particular graph, I hope it is quite visible to you. So they find out in this particular graph, so they to find out, they collect random student data, right, from records, and each student entrance score and final GPA are plotted on a graph like teeny dots. So you can see some teeny dots here. I hope you are able to see. So there are some teeny dots. So what does this teeny dot represent? They collect random student data, right? They collect random student data from record. Each student entrance score. So here you can see exam score or entrance exam, and on the y-axis you can see GPA score, right? Final GPA are plotted on a graph like teeny dot. Now the question is, what does this graph show? What does this graph show? You know, if the dot move upward, it means a student with higher entrance score tends to have higher final GPA. Suppose here is a dot. So it means that a student with higher entrance score, right, tends to get higher final GPA, showing a direct relationship. If the graph move upward, if the dots move upward, right? So if the dots move upward, it means clearly that a student with higher entrance score tends to get higher GPA, showing a direct relationship. So why does this matter? Because this scatter diagram help predict final result. It is useful for decision making. So basically what we come to know, that this scatter diagram visually prove if two things are related. In this case you can see the graph is moving upward. Can't you see it? Please, I hope you can see it easily, that this dots is moving upward, isn't it? See, earlier it was lower, then upward, then upward, then upward. So it is moving upward. So it clearly means that high entrance score is equal to high graduation GPA. High graduation GPA, right? It clearly we can just in this case we can say that. So do you think entrance score alone decide final result, or there are other factor? Let's discuss in the comment. So I hope this make your concept clear. So that is the relevance of the scatter diagram. This is the point which we have just covered now, right? Okay, now like in this case you can see the data pair here. So we can see that there is a direct relationship observed. Higher entrance exam score correlate with higher final GPA, and this we can know by plotting the data points, by connecting the dots. Now let's talk about the types of relationship. You know, there are two kinds of relationship are there. Ever noticed how something are always connected? Like the more you study, the better your grades, or how well the more junk food you eat, the less fit you feel. Well, a scatter diagram help us see this connection clearly. you know there are three main types of relationship between variable. There are how many types of relationship between variable? Three main types of relationship, right? So there are three main types of relationship. The first is called direct relationship. You know that when one increases, that means both variable move together, right? When one increases, other also increase. For example, clearly you have seen in the above case that high entrance examination, right? High entrance examination score, it means higher GPA. Now the second kind of relationship is called inverse relationship, right? This is called inverse relationship. What is the meaning of this so called inverse relationship? Let me discuss. You know what is the meaning of this? See, if one variable goes up, the other goes down. Suppose we have two variable here, let's say, just a minute, yeah. So suppose I have two variable here, this is V1, this is V1 and this is V2. If V1 moves up, V2 goes down. This is what we call as inverse relationship, right? So, and the third is called no relationship. The third kind of relationship is called no relationship. It means what? That no pattern at all. For example, your math score don't affect your English score, right? So let me show you some figure to make it more clear, right? So I will provide you three figure: 4.2a, 4.2b, 4.2c. So let us see here, this is 4.2a. So in this case you can see that in figure 4.2a, it shows which type of relationship. Is it direct or inverse? It shows inverse relationship. This is a scatter diagram, and on the basis of this scatter diagram we can say that suppose one variable V1 here and V2 here. So what does it show about relationship between V1 and V2? It shows that it is an inverse relationship. Why? Because as one variable increases, as you can see here, that if V2 increases, you can see if this variable is increasing, so this variable is decreasing, right? So this variable is decreasing. So that is why it is inverse relationship. For example, more practice time, fewer mistake. Now let's look at, this is about inverse relationship. So looking at the scatter diagram, you can predict whether the relationship is direct, indirect or no relationship. Now look at this diagram. Can you please tell me, looking at 14.2b, whether there is inverse, direct or no relationship? So this is the clear case of no relationship, because the dots are all over the place, right? It does not show any fixed segmentation, meaning though no strong link exists, it is everywhere. You cannot say that it is moving upward or downward. The dots are everywhere, and when dots are everywhere, this is called what we call no relationship. And the third relationship, we have mixed relationship. It starts as inverse but later turn direct. That is how early failure can lead to later success, right? So in a scatter diagram, we can sometimes draw a trend line to predict future outcome, right? What happened in the scatter diagram? What happened that we can draw a trend line to predict future outcome. If the dots follow a certain pattern, we can forecast result with more confidence, right? So that is the point. Now let's talk about the key points on linear relationship. Here it is. So now we know what is the meaning of linear relationship. Have you ever noticed how something follow a straight path? Like the more you study, the better your score, or the more you save, the bigger your bank balance. That is called linear relationship. A simple, predictable connection between two things. Now, so here we are talking about this so-called linear relationship. This topic we are talking about. You know, linear relationship is that it means that as one thing increases, it means if one thing increases, it means that other thing will also increase, right? Other thing will also increase. For example, higher exam score is equal to higher final GPA. So this entrance exam score, here you can see this entrance exam score, this is one variable. So you know this entrance exam score and this graduation GPA, so these are two variable, and you can see they are moving linearly. So this is clear straight line relationship. Now you know, to make a visual proof of it, we draw trend line, right? For visually representation, we can use something called trend line. So imagine plotting this on a graph. If the dots form a straight line, it is linear relationship. If it is moving upward, it is direct. If it is moving downward, it is indirect. See, so first of all, you will draw the trend line, right? You first draw the trend line and you observe it. What you observe? You observe whether after drawing the trend line, what you have to observe? You have to observe that is it forming a straight line? Yes or no? A straight line? Yes or no? If it is forming a straight line, if the answer is yes, now you look at whether it is moving upward or whether it is moving downward. Now suppose it is moving upward, so it means direct relationship. If it is moving downward, it means inverse relationship, right? So this trend line will help you know that whether two variables are directly connected or inversely connected. So again I am repeating, this is super important thing to understand. So first of all, you will draw the trend line, right? You will connect the dots, and you know what is the line. Line is a connection of many points, and you know, if you connect the dots, if you connect the points, we will get a line. And looking at the line, you have to see whether it is a straight line. If it is a straight line, whether the line is moving upward, like this. Let me show you. So this is the graph, it is moving upward. This is the graph, it is moving downward. So you have to see it whether the line is moving upward or moving downward. If it is moving upward, like in this case, so it is called linear. It is called, just to let me know, it is called direct relationship. And if they are moving downward, it is called inverse relationship. Okay, so using the graph, you can predict whether two variables are directly related or inversely related. Now then we have something called curvilinear relationship. This is called twist and turn. Not all relationships follow a straight path. Some are curved. The rise and fall in different way. For example, let me show you one more example to make this concept clearer. So I hope I have drawn one picture. Okay, let me see. Okay, so I will draw it, no issue. I think I have missed it copying from the book, no issue. So curvilinear relationship means what? The twist and turn, right? So let me show you. Suppose I draw a graph here to make it more clear. Yeah, so this is our y-axis, this is our x-axis, and suppose I draw something like this, So this curve, this is a kind of curve. Or suppose I do not, let me draw some other kind of graph. Let me erase it. I draw something like this. So you can easily look that this is not a linear pattern, this is not a straight line, rather it is a curved line. There are twists, there are turns in it, right? So you know, not all relationships follow a straight path. Some are curved, they rise, they fall in different way, right? So in this figure, you can see easily that the data does not fit a straight line but follow a curve in it. So basically in this chapter focus exclusively on a linear relationship. We are not going to look about this curvilinear relationship. So that is an exception. So okay, that is a limitation. We must keep in our mind that currently in this particular chapter we are not dealing with curvilinear relationship, right? So curve one, we will leave those for later, right? I hope this is clear. Why we need to understand it? Because you must know that what are the limitations of this particular chapter. Whatever we are going to discuss is valid only for linear relationship. I hope this is okay. Right, now let's talk about the next point. So imagine you are predicting, just wait a minute. So imagine that you are predicting so both scatter diagrams. So okay, one more thing I want to tell you. Types of relationship we have covered, key points we have covered. So imagine you are predicting exam score based on study hour. So suppose you are predicting exam score based on study hour, right? You see how much hour you have studied, and on basis of that you are predicting the exam score. If everyone who study more score higher, you would say that relationship is strong and linear. But if some top scorer study less and but if some top scorer study less and some low scorer study a lot, so the link would be weaker, right? Try to understand what I am saying. That you are predicting what? You are predicting exam score, right? You are predicting exam score based on study hour. So based on study hour, how much hour are they studying, right? On the basis of that you are predicting exam score, right? So if everyone who study more, right? So let me write it down. If everyone who study more, he get higher, so he score higher. Study more, score higher, right? Then it means that your relationship is strong. It clearly means that it is a strong relationship, isn't it? Now suppose something happen like top scorer. Let me erase this one. So if everyone who study more get more high score, that it means the relationship is strong. But now suppose it happen like that top scorer study less. Now tell me what will happen in this case. Top scorer is studying less. It means that our relationship is weaker. The link would be weaker. It clearly means that link is weaker, isn't it? Or suppose reverse happen, that low scorer study more. So that is exactly what we are exploring today. How strong or how weak a relationship is using a scatter diagram. Now we know what is scatter diagram. It helps us predict the future outcome using, we are connecting the dots. Basically we are looking how the trend is behaving, like is it moving curvilinear, is it moving linear, and if it is moving linear, if it is moving upward like direct relationship, if it is moving linear, if it is moving downward like inverse relationship. So now we are looking at the strength of relationship. We know that two variables are having relationship between each other, but what about their strength? Are they strong? Are they weak? So one example I have given you for a strong relationship, like if you study more, you will score high. Then this is called a strong relationship. But what happened? It happened like that top scorer study less. So it means that our link is weak, right? So now let's see how to compare a scatter diagram, a strong versus weak relationship. You know, the dots follow a straight path close to the trend line, right? So it means that clear and a strong connection. So let me show you what are this picture. So let me draw it for you so that you can easily understand that what I am talking about. So suppose this is a kind of x and y axis. Okay, and now let me draw a line here. So this is our trend line. Okay, and suppose dots are here. Dots are, just wait a minute. Suppose, let me use different color. Dots are here. These are the dots. These are the dots. These are the dots. These are the, I'm shown it by the blue color, right? So these are the dots. So you can easily see that the dots follow a straight path close to the trend line. All the dots are very close to the trend line. So it means that there is a clear and a strong connection, right? When I will say that clear and a strong connection, when the dots are closer to the straight line or the trend line. Now suppose I draw another curve, right? Now suppose I am drawing another graph. So let me draw a straight line here. This is our trend line. A straight line represents the trend line, and now I am using different color. Let me use pink color. Okay, so now suppose our dots are like this. Our dots are like this. Some dots are here, 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 some dots are here. So in this case, in figure number B, and this is our figure number A. So in figure number B, you can easily see that the dots are scattered more away from the trend line, right? So dots are more scattered and don't stick closely to the trend line. So what does it indicate? It clearly indicates that our relationship is weak, right? Relationship still exists, but is not very strong. For example, some who study less still scored well, and some who study more did not perform as expected. So I hope this is clear now. Using a scatter diagram, you can predict whether the relationship between two variables is strong or weak. How to predict it? Quite easy. You have to see the trend line and you have to see the dot pattern. If the dot is more close to the trend line, it means the relationship is strong, and if the dot are more scattered away from the trend line, it means the relationship is weak, right? I hope this make you concept clearer. So now let's quantify it. Let's quantify whatever we have discussed till now. So let's talk about the magic of small r. So there is something called small r, as you can see it here, small r. So this small r magic we are going to see now. You know that we don't just guess how strong relationship is. We don't just guess, rather we measure it using something called coefficient of correlation, right? So using this coefficient of correlation, we can measure the extent of relationship, whether it is a strong relationship, whether it is a weak relationship. We can measure it using a small r. Till now is that r is the magic of r we are talking about, right? So we don't just guess how strong a relationship is, we measure it, and we measure it using something called coefficient of correlation, right? So see, if r is closer to 1, so let me draw a line here. This is 0, this is -1, and this is +1. If r is closer to 1, right, it means that it is a strong relationship, right? So you have to see whether r is closer to 1 or not. If it is closer to 1, then it means it is a strong relationship, and if it is closer to 0, it means weak relationship. Now, ever wondered if more expert leads to more input, or if more study hour actually improve its exam score? Well, that is what correlation helps us find out. It measures how strongly two things are linked. And now I have just told you that the value of r, we use a magic number which we call coefficient of correlation to check how a strong or weak relationship is, right? So just now I have told you that the value of r, it can be 0, it can be -1, it can be +1, and it can be anywhere in this range. So suppose r is +1, it means what? It means perfectly positive relationship. Okay, r is equal to 0, it means what? It means no connection. And r is equal to -1, it means what? It means perfectly negative relationship. Perfectly negative relationship, right? So the formula in simple word is that that we first, so now question is how to find the r, right? So now you understand that what is the meaning of r is equal to -1. R is equal to -1 means that the relationship is inverse. What is the meaning of r is equal to +1? It means perfectly positive relationship. And what is the meaning of r is equal to 0? It means no connection. And the more the value of r is nearer to 0, it means weak connection. And the more the value of r is nearer to +1 or 1, it means a strong connection, right? This you have to remember. Now this is the formula, right? This is the formula which we use to calculate correlation. So let's understand this formula. So first of all, what we do, we find the mean, right? First of all, we find average. We find average of x and y, right? We find average of x and y. You can see we have find the average of x and y. X bar means average of x, and y bar means average of y, right? Then we calculate how much each value deviates from the mean using a standard deviation. Sigma x is equal to summation of x minus x bar chi-square upon n. So this will give you sigma x, and similarly we calculate sigma y. So sigma x and sigma y show that how much each value deviates from the mean. So sigma x is calculated using this formula, and sigma y is calculated using the formula which is summation of y minus y bar chi-square upon n, right? So these two formula are used to calculate the deviation, how much the value are deviated from the mean, right? And then we finally combine this deviation to get r. So you can see the formula is covariance of xy divided by sigma x into sigma y. And what is covariance, right? So covariance, this is the formula for covariance. You can see it here, 1 upon n summation x minus x bar multiplied by y minus y bar upon 1 by n, right? So this is the formula which is through which you calculate the covariance, right? So this is how you will do it. So there is one more simpler formula. If you have two formulas to use, either to use this formula, let me highlight this formula using different color. So either you use this formula or you use this formula, right? No matter which formula you use, right? So this is another simple formula where you use n, where you use summation x, where you use summation y, right? Summation xy, summation x square, summation y square. You can see all these things have been written here. So this is another formula where you can use directly use this, and you can crunch the number to do the faster calculation. This calculation will take time, while this formula will not take that much time, right? And there is an easy way to remember it also. How to remember this formula? Quite easy to understand. Let's see how. Let me tell you how to remember this formula. See, you just remember the numerator. Numerator is summation xy minus summation x multiplied by summation y. Now to remember the denominator, quite simple. You just replace one time y by x, so it will become summation of x square, right? And this will become summation of, just you replace y by summation of x ka whole square, isn't it? You see this is same written. And now you just one time you replace x by y. So if you replace x by y, what you will get? You will get n times summation of, I am replacing x by y, summation of y square minus summation of x by y, summation of y ka whole square, right? So this is what you have, you will see it here. And then you take under root, multiply both of them, this is your denominator. So no need to memorize the formula, just remember the numerator. If you remember the numerator, denominator can be easily be derived, right? Quite simple to derive the denominator. Just remember the numerator, you can easily derive the denominator. Now let us take an example to make this concept more clear. So you can see one example given before you. So you have to calculate the correlation coefficient of the data. So export and import. So you know, export of raw material, the data has been given. So the first data is, you see, it is 42, 44, 58, 55, 89. The data is in crore, right? And import of finished good is 56. So these are two data, and you have to find a small r for this. Okay, how to go about doing it? So just we have to prepare a table. Tabular format is the best one to do it, right? So we have two variables. Let's say x is export and y is import, right? And we need x square, we need y square, we need xy. You see in this formula you can see what are the variable we need: xy, xy, x square and y square. Main thing, these are the things which we need, right? Okay, so x square, y square and xy, these are the three variables which we will need. Now just write x just write y x square. You just make it a square. 42 into 42, this will give you 1764, right? Similarly 44 into 44, this will give you 1936. Similarly do for all these values, right? For all this value you find summation x, you find summation y. How to find summation x? You just add all of them. 42 plus 44 plus 58 plus 55, you just add all of them, you will get summation of x. Similarly to find summation of y, you add all of them. Summation of x square, you add all of them. Summation of y square, you add all of them. Summation of xy, you add all of them. So this is how you got the summation. Now you have to find x bar. What is x bar? X bar is, x bar is equal to summation of x upon n. What is summation of x? It is nothing but 452. Just write 42 here. And what is n? N is the number of observation. What is the number of observation? You can see. So let me show you. 1 2 3 4 5 6 7 7 observation are there. So 452 divided by 7. So after calculation this will give you 64.57. Similarly, what is y bar? Y bar is summation of y divided by n. What is summation of y? This is 427, right? Summation of y bar. So this is 427 divided by 7. So this will give you 61. Okay, so now you know x bar, now you know y bar, right? So just you have to use the formula. What is the formula? We just remember, I told you just the formula. Let me write it down once more. You just have to remember the denominator. You just have to remember the numerator. n times summation of xy minus n times, let me see it, here it is, n times summation of xy minus summation of x into summation of y, right? Correct, we are correct. N times summation of xy minus summation of x into summation of y divided by under root, just replace x by y, under root summation of y square minus summation of y ka whole square, under root n time, just replace y by x. So the under root summation of this will become x square minus summation of x ka whole square. Now what is the, just apply this, just put the value in this formula, right? What is summation of xy? Summation of xy is how much? You can see 28469. So write 28469 multiplied by n. What is n? N is 7. Okay, n is 7 minus, what is summation of x? 452 divided by multiplied by 427. Okay, and now in the denominator, what is the value of n? N is 7. What is the value of y square? Summation of y square, it is 26463, isn't it? 26463 minus, what is the value of summation of y? 427. So 427 ka square. Now the second one, n time, just you put the value, you using the calculator, you calculate it, and the value you will get for r is nothing but 0.8383. Okay, so it is closer to 1, to be more precise. So it means there is a little bit a strong relationship between the export and import. So this is how you will calculate small r. I hope it is clear. Now one more question based on this. You can see the next question is in front of your screen. The question says that find the correlation coefficient. That means you have to find the r, where summation of x minus xy into summation of y minus y bar, I is equal to 1 to 740. I think this is covariance, right? And variance of x is 240 and variance of y is 506 and number of observation is 20. So you just have to apply the formula r is equal to covariance of xy under bracket sigma x into sigma y. Now you know what is sigma x? These are standard deviation, and we know a standard deviation is equal to under root of variance. So if you talk about standard deviation of x, so under root of 204, right? And if you talk about a standard deviation of y, it is under root of 506. Okay, so we know the denominator. Now let's calculate the numerator. What is covariance of x and y? Which is nothing but summation of xi minus x bar multiplied by y minus y bar whole divided by n. You just have to divide it by n, right? What is the n? N is the 20, right? So what you will do, you will divide this 740, just wait a minute, 740 by 20, this will give you 37. So this is called covariance of x and y. So you know covariance 37, right? So just write 37 divided by under root 204 multiplied by under root 506. Just use the calculator to calculate it, the value, and you will get the answer, right? So I hope this is clear. You can use either of the formula. Both formula are for calculating correlation, right? So now understanding correlation. So the correlation coefficient R, I already told you that how to interpret R. If the value of R always lie between -1 and +1, if it is -1, it indicates perfect inverse relationship, right? And if it is +1, it indicates perfect direct relationship. If it is 0, it means no linear relationship, right? So there the value of R lies near +1 or -1, it represents a strong relationship, while the value when near 0, it suggests weaker relationship, right? So I hope this make your concept clear, right? Then we have something called regression analysis. Right. So question is, what is the meaning of this regression analysis? That is what we are going to discuss. And you know, in your book you will see a graph. So with this graph we will talk about right now, right? So let's talk about this so-called regression analysis. So friends, ever wondered how to predict trend like loan dispersal based on past data? Well, today we are cracking the code behind regression analysis in the easiest way possible. Imagine this: you are sorry friends, you are tracking customer deposit in your branch, right? So what you are tracking? You are tracking customer deposit in your branch, right? And you are tracking this data, and if the deposit keep increasing, we can predict future deposit based on past pattern. That is what regression analysis help us do. It find a line of best fit. So let me show you where it is written. It find a line of the best fit. So let me write it down. It help you find the line of best fit to predict one thing based on another. So let me show you graph. Let me show you a graph to make it more clear. This is 14.5 graph. You can see the curve is moving upward, right? This means a positive slope. It means a positive slope, right? So this is an equation. I think you know this equation. You are familiar with this equation. Y is equal to a plus bx. This is an equation of a line, right? I hope you know it. In this equation, you should know that b represent the slope of the line. B represent the slope of the line, and a represent the intercept of the line. X, I think it is y intercept, isn't it? Right? So y is equal to a plus bx. When you put x is equal to 0, you will get y is equal to a. So this represent y intercept, and if you put and b represent the slope of the line, right? So in this graph you can see easily, like 14.4.5a graph, that the b is positive, the slope is positive. Why is it positive? Because you know the line is going upward, means positive slope. So it means that as one thing increases, the other also increases. Suppose this variable is suppose x, this variable is y. So it indicates that positive slope indicate that if x increases, y is also increasing. You can easily see x is increasing this way, so similarly y is also increasing, right? So that is the significance of having positive slope. Now let's see another picture. This is 14.5b. Now in this picture you can see that one is going downward, so that is called a negative slope. Negative slope. This is called negative slope, and in this case b will be negative, b will be less than 0. In this case, what is happened, that x is moving upward, x is increasing, whereas the y is decreasing, right? So think of it like this: if interest rate is increases, so it means that home loan demand decreases, isn't it? Home loan demand decreases. So these two variables are inversely related. So whenever two variables are inversely related on a graph, we can plot it by showing the inverse relationship. If one variable increase, other variable decrease. So to keep it simple, the formula for slope b looks like bit scary, but here is an easy version. So I think this formula might look scary, right? So b, basically what does b represent? B represent means change in y. B represents change in y upon change in x, right? This is what b represent. This is a slope, right? Change in y upon change in x, right? It basically tells us how much y change when x change by 1 unit. So let us make it more clear using one example. So this is the formula for b, right? You see, this is the formula for calculating the b. So what does it mean? It represents that how much y change when x change by 1 unit. For example, if every rupees 1 lakh increase in salary leads to rupees 50,000 more home loan eligibility, then what is b? Tell me. If every 1 lakh increase in salary, suppose salary increase by 1 lakh, right? If for every 1 lakh increase in salary, let's suppose that home loan eligibility is increased by rupees 50,000, and in this case b is equal to 0.5. Why? Because 50,000 divided by 1 lakh, so this will be 0.5, right? So that is what b represent, that is change in x upon change in y, right? So I hope this make you concept clear, that what does b represent? Change in x upon change in y. Now let's talk about a represent intercept, right? What does a represent? A represent intercept. You can see clearly written, a represent y intercept, means that is where the line starts on the y axis. You see this particular graph. Let me show you what does this intercept represent. Let me show you. This intercept represent the point where the line start on the y-axis. So you can see this start from here. So this is the intercept value. -1 is the intercept value, right? Now what if x is equal to 0, right? What if x is equal to 0? If x is equal to 0, what will be the y? Please see this equation. Please see this equation and tell me, if x is equal to 0, this is the equation, right? Y is equal to a plus bx. Suppose I put x is equal to 0, then what is the value of y? Y will be value of a, right? So think of it as the baseline value where there is no change in the influencing factor, right? So what we come to know here, that if three things can be possible, right? So two things can be possible. First thing is that positive slope is there, that means b is positive. It means that both x and y increases together, right? Second thing, that negative slope is possible. It means b will be less than 0. And in this case what will happen, that as x increases y will decrease, or y increases x will decrease, right? So this formula help predict the trend in banking, loans, deposit, interest rate and more, right? So I hope this make your concept clear. Now imagine you are a branch manager and you want to predict next month loan disbursement based on past data. How do you do that? You can do it using the regression analysis. How? Let me explain. You can do this using a regression analysis. You see, imagine you are a branch manager and you want to predict the next month loan disbursement data based on past data. So you use regression analysis. So you will write the formula y is equal to a plus bx. So let me write it down clearly. Just wait a minute. Let me erase it. Yeah, I have erased it. So let me write down the formula clearly. So you will write y is equal to a plus bx. Okay. Now this is our prediction formula. This is what we call prediction formula. This is the formula which will be used. I am a branch manager. I will use this formula to predict the next month loan disbursement. Right. So this is what we call prediction formula. Now this is how our prediction. This is our prediction formula. So what does b represent here? B represent that how much y change when x change, and a represent the starting point of y when x is equal to 0. So let's break it down using an example. Right? So let's break down this using an example. Suppose you analyze past customer spending and found that for every ₹1 increase in salary, you found that for every ₹1 increase in the salary, spending increased by 0.32. Spending increased by 0.32. This is your finding. You look at the past data and you find that if ₹1 salary increases, then a spending increase by 0.32 rupees. Okay. Now you know it very well. So that is our b value. This value 0.32 is our b. I told you b, right? If one value of one variable increase by 1 unit, what will be the corresponding change in the value of other variable? This is what b gives us. So in this case we can see the b is 0.32. हिंदी में बोले हमारे पास दो वेरिएबल है, यदि एक वेरिएबल में 1 यूनिट का इंक्रीज होता है तो बाकी दूसरे वेरिएबल पे उसका क्या असर होता है, यही तो हमें b बता रहा है. और इस केस में हम देख रहे हैं कि 0.32 का इंक्रीमेंट हो रहा है. दैट इज वाई द वैल्यू ऑफ b is 0.32. राइट. Now if someone earns ₹70,000, so what we will do, we will substitute so basically this formula we are talking about. So this is the value we get, right? So this is the formula. So if suppose someone is earning 70,000, so we will substitute in the place of x 70 and we will get the value y, right? So before going to that detail, let me tell you how to find the value of b. So this formula you have to remember. right? To calculate the value of b, you have to remember this formula. It is quite easy to remember, right? It is nothing different like the correlation. Correlation में आपने देखा होगा, you have seen in the correlation, like summation of x into y minus x bar into y bar. There it was like this. Because why I am relating it? Because it will be easier to remember by relation. N times summation of xy minus summation of x square. I think it was summation of x. Just let me see. Yes, so here you have seen the formula of correlation. You can see it here. Here it is. Yes, n times summation of xy minus summation of x into summation of y. That was the formula there. And now if you go to the regression equation, and this is the formula we are talking about. Yes, this formula we are talking about. So this is what 1 upon n multiplied by summation xy minus x bar into y bar upon 1 upon n into summation of x square minus x square. So just you replace y by x, you will get this denominator, right? So this is a question based on it. Given that in the example, estimate the value of y when x is equal to 70, we use the value of x bar, y bar, covariance xy, xx found in the example. So same question, same data. So your covariance has been given, x bar has been given, y bar has been given. You have to find the value of b, right? So what is the formula we have to use to calculate the value of b? Either you can use this formula, b is equal to covariance xy upon s square. You can use this formula, right? So we have used this formula in this particular question. We first calculated the covariance, which is given to us 128.23, and then we calculate sigma x square, because we have to divide it by sx. Sx means what? A standard deviation of x, right? So x square. So just you have to find what is the standard deviation of x, and you know the formula very well. 1 upon n summation of x square minus x bar ka square, right? So you know what is x bar? 64.57. Find it a square. You know what is x summation of x square, right? Which is 31940. How to find that? You just add all the value. We have just calculated in previously, right? I am talking about this question. Just we have done it. Just we have done this particular question. You remember it? In this question you see what is the summation of x square? 31940. That is what we have used the data. इसी डेटा को हमने यहाँ पे यूज़ किया है. That is the data we have used here, right? So after substituting the value, we are getting sigma x is equal to 19.84, right? And b is equal to 0.3258. So just put in the value, just put in the formula, y is equal to a plus bx, we know. So what is the value of y? Y is y, a plus b. B just write 0.3258 upon x. Now you have to find the value of a. How to go about finding value of a? How to go about finding value of a? So to get the value of a, what you will do? So a is equal to y bar minus b times x bar, right? So what is the value of y bar? Y bar is given 61 here. Here you can see you have to find the value of y bar, which is 61 here, and b you know, x bar you know, corresponding to, so you can find a. So a will give you 39.96, right? So this way you can predict the value.